Thank you for considering my application for the Data Incubator Fellowship. My name is Adam Sonnenberg, and I'm going to talk about Markov chain simulation to predict deposition in Arabic geometry. So first, the background is that respiratory diseases affect millions of people around the world, and there's a lack of good strategies in order to target specific regions of the lung. The geometry of the lung can be described from a diameter, a length, and a phi. And RABI has a publicly available data set which you can download, which will give me the geometry for various animals, including a dog, a hamster, a beagle, and a human being. And we can take that geometry and we can use that to simulate the probability of a particle depositing inside of it. So what determines if a particle is going to deposit inside of a geometry? It's determined by the three forces that act on the particle. The first one is the force of gravity, the second one is the force of diffusion, and the third one is the force of the fluid drag on top of the particle. Each one of these forces can be converted to an equation which basically gives us the probability of a certain flow rate depositing by gravity in a single particle. This is for diffusion, and for impaction is the next two. And now each probability is a function of the flow rate. So the geometry is fixed, and the variable we're going to be sweeping across this network is going to be the flow rate Q. And we're going to be investigating at what flow rate for each individual geometry would maximize the given probability of a particle depositing at an individual bifurcation. And to do that, we will model it as a Markov chain where we can calculate the individual transition probabilities of going from the first state to the second state in our tree, and that will enable us to simulate a Markov chain. And this is what I've already simulated, which is the transitions realized by simulation of a 3-generational tree using realistic geometry. And if accepted to the Data Fellowship, I will then work on this problem with a mentor, and I would relish the opportunity to come. So please consider my application, and thank you.